Alright, so you started looking at sex-linked diseases in the Flintstones, and now we're going to look a little bit deeper at them. So, today's lesson we're going to look at the difference between gene and chromosomal mutations and their causes, and then you're going to be able to do sex-linked Punnett squares, and we're going to bring pedigrees back up and do sex-linked pedigrees. So, the reason why this is important is, well, the first thing about those mutations is a chromosomal mutation is actually what causes Down syndrome, which I know you guys all pretty much heard of. And then we got the Russian royal family here, hemophilia. That's a severe blood disease where you keep constantly bleed and you can't clot, and can be very deadly. And here is an example of one going through a family, and we can look at other chances in other families. So, our sex-linked notes here. So we already did the relevance there because of these diseases. And then my computer is being slow. Oh, come on. Alright, so remember we have 46 now it's being all funky because it's trying to catch up here. Alright. So we have 46 chromosomes, and remember these last part of chromosomes here, our last pair, our 23rd pair, is the sex chromosomes. So we have 46 in our chromosomes, the 23 pairs, and these are the sex chromosomes. So you can circle those right there, the X and the Y. So this is a male. Meiosis makes gametes with 23 chromosomes. Alright, so I'm just trying to go fast, so I'm not writing all this stuff in, so you're going to have to at least listen for some of it. So, gamete with 23 chromosomes. So here's our gamete. What sex chromosomes can the males pass on? Well, they can pass down an X or a Y. You're going to pass down the X or the Y. They only pass down one of them, whereas the female can only pass down the X. Alright, so that's what we're going to talk about in a little bit when we go into sex-linked Punnett squares. And then fertilization makes a zygote that will have 46 chromosomes, and they get 23 from the mom and 23 from the dad. All right, at least that's not what normally happens. So that should all be review. All right, so now let's go on to this chromosomal mutation here. Alright, so first, we talked about gene mutations, again, a review. And a gene mutation, remember, is a change in the nucleotides in the DNA, or the bases, which affects the protein. Alright, so what is a gene? A gene, remember, is a sequence of DNA that codes for a protein. Alright, which determines our trait. So example of a gene mutation would be like ATTTTCG, and that normally codes for UAAAGC. And then I'm not going to bring out the codon chart, but let's just change that from, let's say that's Lu and that's ALA, 2 amino acids. And then if we get a mutation, ATTACG, that might be UAA, so this one's the same, Lu. But then this one is UGC, so we have a different amino acid, like lysine or something like that. Alright, so that will change the protein. Alright, so again, that is a review, and that's caused by just random mutations. Alright, so now let's look at a chromosome mutation. So for Down syndrome, if you look here, we have 3 chromosomes at number 21. Everyone else, we only have 2. This one, and this one's a girl because there's 2 X's, has 3. So that is going to be the problem with Down syndrome. With Klinefelter syndrome, we have 3 chromosomes again, but this time we have too many here on the X and the Y. 2 X's and 1 Y. So we have too many chromosomes. And then Turner syndrome, we actually have 1 less chromosome. Alright, we only have 1 X instead of 2 X's or an X and a Y. Alright, how does this cause? Well, remember, if we go back up to are meiosis. So remember, a guy will pass down either X or Y, and a female will pass down an X. Well, sometimes these two won't separate during meiosis, and then the boy passes down an X and a Y in the sperm, and the female passes down an X in her egg. So then the baby will get XXY. All right, and then it's a male, but it has some female characteristics called Klinefelter system. If that sperm if these X and Y didn't separate, remember half of them go to one sperm and half of them go to another? So one sperm might have the X and the Y, so that means the other sperm didn't get anything. If that happens, then you have a zygote that just has an X, one X. And that one's still a female, and usually not too many problems with that person. And then Down syndrome, still the same thing, just not dealing with the sex chromosomes. You have 21. For some reason, so this is normally our cell after meiosis, it only has 121. Well, again, instead of having one, we get two. And the same thing with the sperm, we might have one, in the sperm. So usually it's the female that causes Down syndrome here because their eggs don't divide very quickly. And then when they bind, they get 3, and that causes Down syndrome. So usually older women have more chance of getting a child with Down syndrome because their eggs have been dividing for a long time, and the chromosomes don't separate. So it's all during meiosis that causes chromosome mutation. So if you want to put that here, meiosis causes the mutation. Alright, so now let's go down to our sex-linked Punnett squares. So this one's filled out for you. So we did a little bit of this on the Flintstones already. So what's the mother's genotype? Well, remember the mother is right here, so it's X, she's a carrier, X big H, X little h, so the father is X big H, Y. There is no allele on the Y chromosome, so you leave that empty, and there are only alleles on the X chromosome. So sex-linked genes are genes that are only found on the X chromosome. Alright, so a female is homozygous dominant for no colorblind, and a male is colorblind. So then you do this, and then remember, when you do your Punnett square, you have X big R, X little r, one X big R from the top, one X little r from the side, X big R from the top, X little r from the side, X big R from the top, Y from the side, X big R from the top, Y on the side, and you get 0% with colorblind because they all have a big R. Alright, so now if we go to the next one, alright, a female is carrier, so carrier is big R, little r, and a male is not colorblind, so big R, Y. Again, what percentage chance is their children going to be colorblind? So X big R, X big R, X big R, X little r from the top, X big R from the top, Y, X little r from the top, Y, and you get a 25% chance. Just one that's going to be colorblind, and they're going to be a male. Alright, so now again, a female is a carrier, and the male has colorblindness, so X little r. So again, you do your Punnett square like normal. Alright, so what percent chance of their children again? So X big R, X little r, X little r, X little r, X big R, Y, X little r, Y. So now it's going to be a 50% chance that their child has the disease, and it will either be male or female. Alright, so we're almost done here. Last one, a female is colorblind, and a male is not colorblind. So now X big R, X big R, X little r, X little r, X little ry, X little ry. So now 50% again of their children are going to have the disease, but it's only going to be in their boys, only males. So who do the males always get their genes from? Well, if you look here, the Y chromosome is given to the males from the guy. Does the Y chromosome have any genes on it? No. They always get their genes from their mother. Alright, so mother will always donate their genes to their son. And who has a greater chance of having a sex-linked trait? Well, if you look here, 50%, and they were all males. And then above, there was another one that was only males, and there's all males because they do not have they can't be carriers. Only females can be carriers, so the female can have that big letter to override the recessive letter. Alright, so now let's go through these pedigrees down here quick. Well, actually, we'll stop there and we'll come back to the pedigrees later.